right, Mr. H here for day 2 of complex numbers. We chatted a little about adding and subtracting and multiplying and some generic breakdown yesterday. Today we are going to be discussing division, which is the most interesting part and the most complex part of complex numbers. Because similar to when we said we cannot have a radical in the denominator, we cannot have I in the denominator either. You're like, oh, that's wonderful. Oh, moving. Hang on a second here. There we go. So when we do this, how are we going to fix it? Well, when we had the radicals before, we had the issue of we'd multiply the numerator and denominator by that radical. And this is similar in the way that it's going to work. Here's the deal, though. We're going to multiply by what's called the complex conjugate. Here's what that means in English. Whatever binomial you see in the denominator, or even if it's a monomial, we're just going to change signs. So when it's a binomial, we just change the sign in the middle. So since this was 2 minus I use 2 plus I. If it's plus, we're going to use minus. And so from here, we just have this game we have to play. We have to FOIL or multiply these out. So I'm going to do a little side work here. Not doing a boo-boo. I know that normally means the post-it, I'm going to have a boo-boo. Not in this case. So 5 plus I, 2 plus I. So we got 10 plus 5I plus 2I plus I squared. Quick reminder back from the last lesson. What does I squared equal? -1. So this is really -1. Because that makes it a lot easier when I go to combine like terms. 10 minus 1 is 9. 5I and 2I is 7I. Standard form, A plus BI. So 9 plus 7I, I'm going to put this back in a second. I just want to get it over a little bit. So 9 plus 7I. And then I do the same thing to the denominator. Now, there is going to be a trick with this, or a shortcut. I'm not going to just tell you. I want you to see what it is. So I start to FOIL again. I'm like, okay, so 4 plus 2I minus 2I minus I squared. A couple things to take note of. Plus and minus 2I cancel. That will happen with your denominator every time because we can't have I in the denominator. That's why we do it this way. Now, remember here, this is minus -1 because that's what I squared is. So it's going to change signs to +1. 4 plus 1 is 5. 5. Make sure that you don't have a common factor between all three of these. So, I mean, let's say it would have been, I don't know, 5, 10, and 15. Then I still would take the 5 out of all of them. I would divide that out. But if not, that's all you got. Okay? We're just making sure that that denominator does not have an I. Same here. 1 plus I, 1 minus I. And play the same game. So you're like, is there a shortcut to the numerator? Nope. Just got to do what we got to do. So first, outer, inner, last. 4 times -1 is -4. 3 minus 4 is -1. -3 minus 4 is -7. Movement here again. So -1 minus 7i. And then my denominator, okay, let me pull the old one back up here for a second. Notice what was left after I did all my multiplying. The first terms and the last terms. So you're like, I really don't have to do the O and the I? Not really. I mean, it doesn't hurt if you do. But if I have 1 plus I, 1 minus I, really it's just 1 times 1 is 1. I times -I is -I squared. But what is it really? 1 minus -1, which is 2. And I'm good. Okay. What about if it's just like 7i? There's nothing else there. Do I have to do -7i? Not really. Okay. If you like to just be a creature of habit and you're like, I'm always changing the sign, I'm going to change the sign here too. You can. But when it's a monomial term, when it's just one term, you do not have to. Just something to know. So let's see here. 21i plus 14i squared, we'll deal with that in a minute, over 49i squared. Okay, simplify time. 14 times -1 is -14. Standard form. I squared is -1. 49 times -1 is -49. This is the situation I was talking about on the first one. Are these all divisible by something? Yes, they're all divisible by 7. So for my final answer, just like with any fraction, we simplify to as far as we can. So if we divide each of those by 7, I get my answer. Now, if some of you did the -7i, you're going to end up with 2 minus 3i over 7. Same answer. If all of your signs are exactly the opposite, it's the same thing. That sounds weird, but it's true. Because if you had, negative divided by negative is positive. If this was 2, or positive divided by negative is negative. It doesn't matter if that's negative or this is negative. I get to the same place. So that's the roughest part of this section. Straight up honest. We are not going to worry about making the statement true here. Okay? Again, we pick our battles. Solve the equation by showing work. Okay, we'll do a couple of these. Get x squared alone minus the 5. Oh, 2 things to remember. Do you remember them both? When we square root, plus minus, and since we're taking the square root of a negative, what else? Pull an I out. And if the radical broke down further, we'd break it down further. But since it doesn't, we won't. One more of these. I want to do 25. Again, just like algebra, I want to get the x term by itself. So we will minus the 84 over. We will divide by 7. Okay, here come the 2 steps again. Heads up, there's going to be a third one this time. Plus minus, pull an I out, and then reminder, 12 has a perfect square as factor. So that 2 that gets out of radical jail can hang out with I. 3, though, still acting irrationally, has to stay in radical jail. Okay. Last part. Okay. Actually, I'm going to do 1. I'm going to do 29 too. But when we get down here, we chatted about this the other day when we had our I squared, I to the third, I to the fourth, and that trick that was involved where I can take whatever my exponent is, divide it by 4, and the remainder will tell me which one of those it's going to be. Let me kind of come back here again. Okay, so when we were back here before, we said, hey, if we divide that in, instead of going round and round and round in a circle, we could get there. So what we're going to do is we're actually going to put that into play here. So I to the 20th, 20 divided by 4 is 5. There's no remainder. So what's that mean again? Okay, let's play on here and then we can remember. Whoa. So we got out of the first 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you're like, now wait a minute. So when we saw this before, when we got to here, why is this, remainder, why would it be remainder 4? Well, let's think about this for a second. If 4 went in evenly, if 4 goes in evenly to something, there's not going to be a remainder. So here, remainder 1 would get me I. Remainder 2 would get me I squared. Remainder 3 gets me I to the third. And here, since 4 would go in evenly, remainder 0 gets me I to the fourth. So you're like, that's kind of weird. Well, math, it's math. Math is weird. So here, this would be I to the fourth, or, if we keep flipping back and forth here, 1. Or here, 31 divided by 4. Remainder 3, which means it's I to the third, which means it's what again? I know it's early. I'm not going to have you know what's off the top of your head. Negative I. And that's it. And we'll finish up with something easy here. Now, this looks like it's going to be complicated. Trust me, it is not. We have an AC circuit. We got voltage. We got current. We got impedance. We got this formula. Read carefully what's being asked for. Find the voltage in a circuit with current 2 plus 4J amps and impedance 9 minus 3J. So let's look at this again. Current and impedance. So current times impedance equals voltage. Find the voltage. 2 plus 4J times 9 minus, oh my goodness, 9 minus 3J. We're just using the formula. Okay. Look for words. Like in the last one that we're not going to do, it says add. So you're just adding like terms together. Here, I'm going to multiply. So let's see here. We got first, outer, inner, last. You're like, wait, is J, oh, J represents the imaginary unit. That's like my I. So negative 12 times negative 1 would make this positive 12. 18 plus 12 is 30. Negative 6 plus 36 is plus 30J. And that, ladies and gentlemen, would be our voltage. Now, you know me well enough at this point. We're like 6 weeks in. You know I'm not going to expect you to do 33 problems, right? I hope so. Because if not, you've like had me on mute or been paying no attention to what I've been asking you. So when you get over here, again, just get a good mixture. Little add, little simplifying with the complex conjugate, pulling an I out, doing some equation work, just some of the basics, because I'm going to hit you up again when we get to Delta Math anyway. So just enough to get some practice before we get going. Now, for those of you that do use the tracker or start to look ahead, start looking ahead. We got a special guest coming on Wednesday to help us out a little bit with remembering and kind of getting a jive here going with completing the square. I got a YouTube sensation coming in to help out with this. So make sure you're ready and raring to go for that on Wednesday. But otherwise, you know the drill. If you got questions, let me know. And otherwise, have a fantastic day, and we'll see you for next time.